Welcome. This is Coach Dorf. We're in section 4.2 and we're looking at a homework example. In this example, we're given a particular function, f of x equals x cubed minus 3x plus 2 on the interval from -2 to 2. And we're supposed to show that the hypotheses of the mean value theorem are satisfied and then determine all the values of c that satisfy the conclusion of the mean value theorem. So let's start off by first reviewing what are the hypotheses of the mean value theorem. So the hypotheses of mean value theorem. Well, there's two. One is that f is continuous on the interval from a to b. And the second is that f is differentiable on the open interval from a to b. Notice that the continuous is on the closed interval and the differentiable is on the open interval. Well, our function f here, which is x cubed minus 3x plus 2 on the interval from -2 to 2, satisfies these hypotheses. And why is that? Well, that's true because our function is a polynomial, and polynomials are continuous on every interval, and it's also differentiable on every interval. Okay, so we could say because f is a polynomial. All right, so what then is the conclusion of the mean value theorem? Well, that is that there is a number c such that the derivative of f at c equals f of b minus f of a over b minus a. All right, and what does that exactly mean? Well, it means if I graph my function here, let's say my function looks something like this. Okay, it's a continuous function and it's differentiable. This point here we're going to say is a f of a, and this point here is going to be b f of b. What does f of b minus f of a over b minus a equal? What does it represent? It's the slope, okay, of the line that contains a and b. So it's the slope of this line. It's the slope of that purple line right there. And what the mean value theorem then says is that there's going to be some point in between a and b such that if I look at the derivative of the function at that point, it's going to have the same value as the slope of that purple line. Remember, the derivative represents the slope of the tangent line. So if I take a point like this here, right about there, and we'll call that point C, what does the blue line represent? The blue line represents the derivative at C, which is the slope of the tangent line. And notice that that blue line slope has about the same slope as the purple line. So that's what the mean value theorem says. Okay, so let's go back to our function here. Remember, here we have f of x equals x cubed minus 3x plus 2, and we're on the interval from -2 to 2. So we need to find f of b minus f of a over b minus a, and that's supposed to equal f prime at c. So f of b would be, in our problem, would be f of 2. So if I plug 2 into my function, I get 2 cubed minus 3 times 2 plus 2, which is 8 minus 6 plus 2, which is 4. And if I do f of -2, I get -2 cubed minus 3 times -2 plus 2, and that's going to be -8 plus 6 plus 2, which is 0. So my f of b minus f of a over b minus a in this problem would be the same as f of 2 minus f of, oops, let me redo that here. f of 2 minus f of negative 2 all over 2 minus negative 2. And we just saw that f of 2 was 4 and f of negative 2 was 0. So I'm going to have 4 minus 0 over 4 in the bottom, which gives me 1. And what's the derivative of f? Well, using my function f here, okay, if I take that derivative, it's going to be 3x squared minus 3. So if I put in a c there for x, I'm going to get 3c squared minus 3. And the mean value theorem says that this and this are equal to each other, and we just need to solve for c. So I'm going to have 3c squared minus 3 equals 1. All right, I'll add 3 to both sides, and I get 3c squared equals 4. Divide by 3, and I get c squared equals 4/3. Then I take the square root of both sides, and I get c is going to equal plus or minus the square root of 4/3, which is the same thing as plus or minus the square root of 4 over the square root of 3, which is the same thing as plus or minus the square root of 2 over, clean that up here. It's the same thing as 2 over the square root of 3. I can leave the square root in the denominator. I don't need to get rid of it. And this is approximately equal to plus or minus 1.15. All right, but I'll leave this as my answer. And I noticed that that both of those numbers are in the interval from -2 to 2. Okay, if one of them is not inside that interval, then I cannot include that as an answer because my c value has to be within that interval. And then just one last thing I want to mention here. If I were to take the graph of this function, it's going to look something like this. So I'll draw my grid in here, my x-axis, my y-axis. And if I sketch the graph of it, it's going to look something like this. It's going to have these points here. Okay, that's the graph on the interval from -2 to 2 of my function f of x, which was x cubed minus 3x plus 2. Now, we figured out here that the derivative, value of the derivative was equal to 1. So that would be saying that I've got this here, or sorry, not the derivative, but the value of f of 2 minus f of -2 over 2 minus -2, that was equal to 1. Oops. Yes, sorry. Made a few mistakes there. That was equal to 1. Okay, so now there's got to be points. That's that slope there of that line. Okay. Now, the mean value theorem says then that there should be points between x equals -2 and x equals 2 that are going to have, when I take the derivative of the function at those points, it's going to have the same slope as this. And what's that going to look like? That's going to look something like this, and maybe something like that there. And there is my value c equals plus 2 over square root of 3. And if I go down here, okay, that's going to be my value c equals -2 square root of 3. All right, notice the slope of the purple lines are similar, look like they have the same slope as the blue line, which was 1. Okay, and notice that my two c values are between 2 and -2 here, because here's a c and here's my other c. They're between those two values. All right, hope that helps.